So today we are going to learn about chemical kinetics. In the chemical kinetics we are going to see zero order reactions. Okay, so zero order reactions. So first you can put zero order reaction. Zero order reaction. Dear students, you can see full video. So here I am going to explain how to derive K formula and what are the graphs you will get in this derivation, and T half I am going to explain. Based on that one, problems I will give, and how to problems you can solve based on T half with shortcut formulas I am going to discuss. Okay, problems also we are going to discuss. So zero order reactions, now how to define. Okay, the reactions in which the reactions in which rate of reaction directly proportional to directly proportional to concentration of reactant where power raised to zero, okay, this one. So let us say reactants are converting into products. Okay, so for this one rate of reaction, what we can write now, we can write rate of reaction. Okay, rate of reaction. So this rate of reaction, this one I am going to write as a ROR. R means rate of reaction. Okay, is directly proportional to concentration of R where power raised to zero. Okay, something power 0 means how much? It's 1. Okay, so here we can write rate of reaction is equal to, if you want write, means we have to write one constant, that is equal to what? R power 0. Okay, R power 0. What is K here? K is equal to what here? Rate constant of zero order. Why means it is, we are discussing in zero order, so K is equal to rate constant of zero order. K also it can be first order rate constant in first order reactions. Okay, so here what we can write, a rate of reaction is equal to K into R power 0 means 1 we can write. Okay, 1 you can write. Okay, or if you are not writing also same meaning only. Okay, right. So here this is the formula. From here itself you will get one question. Okay, so rate of reaction is equal to K. So many students they will confuse how to find out the K in a zero order. So sometimes they will give ROR, that only you can take as a K. So here we will get a one graph based on this one. Okay, so it is the first equation. Based on this we will see one graph. So here see graph. So rate of reaction is not going to depends on what? Concentration of reactant. So let us say on y-axis we are taking rate of reaction. They may give rate of reaction or rate they may give. Both are same. Suppose if you take a concentration R naught you can take, or you can take as a concentration of reactants. Okay, so it is what? It is independent. Rate of reaction or rate is what? Independent on what? Initial concentration. R naught or A, whatever, concentration of reactant, anything they may give, reactant, anything they may give. Okay, so what we can say, rate of reaction is what? Independent on concentration of reactant. Okay, so now we will see the derivation. Okay, alright, so this formula you remember, rate of reaction is equal to K. Next we are going to see one question based on this. Okay, right. Now for this reaction, reactants are going to convert into products. No, tell me for this one rate of reaction what we can write. We have studied in the introduction of chemical kinetics, they like ROR is equal to minus dr by dt. Okay, so here rate of reaction means what we can write, it is a decrease in the concentration of reactants by dt, that is equal to K you can write. So you can send this dt this side, you can write send. So dr is equal to, we can write k into dt, we can write. Okay, now for this equation, okay, you can multiply with okay, minus. Okay, for this equation you can multiply with minus, then what will happen? Minus into minus na plus, then dr is equal to minus k dt, you can write minus k dt. Let us say it is second equation. For the second equation, integrates both sides, integrate both sides, then what will happen? Okay, integration of dr is equal to, we can write minus k into integration of dt, we can write. So we can write integration, if you remove na, r is equal to minus kt plus, okay, I you can write. Okay, this is equation 3. Okay, this is equation 3. Now see, in this equation 3 we are applying some conditions. Okay, that is what now, here reactants are converting into products, means at time 0 seconds, time 0 seconds means reaction not yet started, that concentration of R we can take it as R naught. So products what? 0. Products won't form that time. Okay, so this is what equation 4. Now, okay, equation 4, those are conditions only, not it's a equation, it's conditions. Okay, so conditions at 4, conditions at 4, substitute in equation 3, then what will happen? Okay, r at time 0, r is what, nana, r naught minus k into, what is the time here? 0 plus I. So what will happen now here? R naught is equal to, you will get I you are going to get, right? This is equation 5. Okay, now equation 5 we have to substitute in what? 3. Okay, the equation 5, this one you are taking and you are substituting in what? Equation 3. Right, now what will happen here? Okay, so instead of r you can write r naught, right? So r naught is equal to, you can write minus kt. Okay, minus kt plus, okay, sorry, here instead of r naught, instead of I you can keep instead of I you can keep r naught, you can keep. So what we can write here? We can write r is equal to, you can write minus kt plus r naught, you can write plus r naught, you can write. Now what we can write here? This r naught you can take this side, then what we can write? Minus kt is equal to, you can write, okay, r minus r naught, you can write, right? Okay, for this one okay, you can multiply with minus for this equation. Okay, for this total equation you multiply with what? Minus. Okay, then what will happen here? Kt is equal to, okay, minus into minus plus, kt will come. So here r is what? Plus is there, so it will become what? Minus. So minus r, here minus into minus it will become plus. So what will happen? R naught. For r naught, minus is there already, minus into minus na plus. So k is equal to, we can write r naught minus r by, okay, t you can write, the rate constant. T means time, the rate constant. How we are calculating? K is equal to, we can write r naught minus r by t, you can write. So here what we can write here? K means rate constant of 0 order. Okay, now r naught is equal to what we can write? Okay, initial concentration of reactant, and r means what we can write here? Final concentration of reactant, t means what? Time taken. Okay, and this is also you can write like this. Okay, r naught is equal to, you can substitute a, initial concentration. Okay, now r is equal to, you can substitute a minus x, you can substitute, then what you will get here? K is equal to a, r naught means a minus x by t. So what you will get here? K is equal to, okay, you will get here k is equal to, okay, a minus a plus x you will get by t. So A cancels, so you will get finally K is equal to X by T. X means what here? Amount of reactant reacted. Okay, amount of reactant which is already reacted. X is equal to amount of reacted. Okay, so how we are saying like this? X is the amount of reactant. X means what? Initial concentration. A minus X means final concentration. The difference will be what? Whatever the amount of reactant reacted, or we can say what? Concentration of product also you can say. You can say here concentration of means the amount of reactant reacted will be must be converted into product now. So you can say concentration of product also you can say concentration of product. Okay, this one. So now in this derivation some graphs we are going to see. Okay, some graphs we will see. So from this one here is there. Okay, from this you can plot a one graph. Okay, so let us this one erase. Okay, this one will take what is that? R is equal to minus KT plus R naught we are having. So which graph we can plot from this one? Y is equal to mx plus c. So on y axis we have take R, x is m, slope is what? Minus k, x axis time, and c is what? R naught. Now see here so on y axis we are taking R and x axis it is the y axis, so that's why on at y what we got? R we got. So R you can take, on x axis you can take a time you can take. So which slope we are having? We are having a negative slope is there with the y intersect. So it is slope is how much? Slope is equal to minus k. What is the y intersect here? R naught is the y intersect. Okay, this is the graph. Okay, so whatever here y is equal to mx plus c is there. No, in that one on y axis we are having R is there, on x axis we have taken time, and slope is negative slope. Okay, c is what? Concentration, that is R naught. This graph will get. Okay, write these reactions. Okay, examples for zero order. Okay, first thing, all enzymatic reactions are zero order and second one is H2 plus Cl2, all which are catalyzed by light. Okay, 2HCl, it is what? Zero order reaction. And third one is dissociation of ammonia will dissociate under the platinum surface to N2 and 3H2. These are zero order reactions. So remember, some students they will ask, sir, how to remember zero order reactions? Sir, means these are examples what they have given, we have to remember. The reason is, suppose if you give some strange one reaction, if you give unknown reaction, if you ask whether it is a zero order or first order, means we cannot say. The reason is order is the experimental quantity. Okay, we will be having tabular problems and all we will solve. No, tabular problem, by that we will identify the order. Okay, order is a purely it's experimental quantity. Okay, so here for this equation what we'll write? Rate is equal to, we'll write k into H2 power 0 and Cl2 power 0. Why? Because the order is zero order. Next, rate is equal, for this one what we can write? K into NH3 power 0 we can write. Got it? These and all. Okay, so remember the second one is what it is? It is what? Light catalyzed reactions. Okay, and third one is what? Dissociation of ammonia under the platinum surface. Okay, right. Next one we are going to see T half of a reaction. Okay, next one we are going to see T half of a reaction. Okay, so half life of a zero order reaction. Half life of a zero order reaction, half life of a zero order reaction. Okay, half life of a zero order reaction. Here how to define half life of a zero order reaction? Now the time taken to reduce, the time taken to reduce its initial concentration into its initial concentration of reactant into half called as okay, half life. So let us say reactants are converting into products. So at time 0, what is there here? Time 0 second, we are having initial concentration as a R naught, so products will not form. But as time is going on, at time is equal to T half na, the initial concentration is becoming into what? Half, right? These are conditions na. These are conditions we are applying in the equation. Okay, what we are having? Equation K. Okay, K is equal to R naught minus R by okay T we are having. In this one we will apply these conditions. So K is equal to okay R naught na initial concentration, final concentration is what? R naught by 2 by T half, right? Okay, T half. Why? Because T half we are finding. Okay, T half is equal to okay, what you will get here? R naught by will get 2K will get. Okay, T half is equal to R naught by 2K. This is the important formula. And also this one we can write as T half is equal to R naught means initial concentration. A by 2K also you can write, not a problem. R naught and A are what? Initial concentration of reactants. R naught and A we can write what? Initial concentration of reactant. Initial concentration of reactants. Okay, K na rate constant of zero order. Rate constant of zero order. So from this one we can write one formula. We can write T half is directly proportional to A in which one? In zero order. So what we can write? T half of first by T half of 2 is equal to, we can write A1 by A2 we can write. Got it? Okay, this is very important formula. Okay, right, this one. So right now see general observation. Okay, we will have one graph here. Okay, so from this T half is directly proportional to A now. By this we can have one graph. So we can write T half okay, if you take on x-axis is T half and initial concentration A or R naught if you take on okay sorry T half if you take on y-axis and x-axis if you take A now, you will get a slope, positive slope you will get. Okay, from the origin. Why? Because it's directly proportional. Okay, right. Now see here in this one common observation I will tell you, so you can solve the questions okay without formula. Suppose see I am taking any reactant I am taking. So reactants are converting into products. So reactant concentration I am taking 100 molar. Why? Because it is easy, 100 to 50. Okay, half life like that. 10 also I can take, but it will be some students they will feel difficult. So, okay, so 100 to 50 to complete initial concentration is 100, it is became to 50 molar within 1 T half. Correct? That is only T half. No, the time taken to reduce its initial concentration into half. Suppose in another T half, what will happen? It will become 0. Okay, means within 2 T halves total reaction will be completed. All reactants will be converted into products. Means we can write this one we can write okay, time taken for 100% is equal to, we can write 2 T half, we can write 2 into T half. Okay, now time taken for 50% is equal to what? Nothing but that is what? 1 T half only, nothing but T half only, not a problem. Now okay, time taken for 75% is equal to what? We can write, just you think, Okay, okay, it is symmetrically it is completing. First 100 molar means within 1 T half it is becoming to 50. In another T half it is becoming to just 0 directly. So from 100 to 0 it is completing. No, it is 100 percentage. So that's why we have taken T 100 percentage is equal to 1 T half and another T half. 2 T half we have written. So now what I am asking, from 100 to, okay, become to 75 percentage, how much it is required? So it may be what, 1.5 into T half. No, yeah, it is correct only, not maybe, accurately you will get. Now time taken for 25 percentage means what will get here, 0.5 into T half you will get. Okay, this one. These are the formula, shortcut formula. Suppose if you know the T half now, if they are asking time taken for 7500, directly you can use this formula. If you know the T half, if you want to calculate time taken for 25%, you can use this formula. Okay, 100% na this formula. Okay, now see, we are observing one common observation. Okay, so we are going to observe one common observation. One question I will give ma. See, question is that 10 molar one reactant is there, to become to 5 molar, the T half taken, okay, let us say 2 minutes. Okay, initial concentration was 10 molar, to become 5 molar, the T half time taken what, 2 minutes. Suppose if I double the initial concentration, so 20 molar. So in this one T half, within 1 T half, how much reactant concentration will be reduced? Okay, see, initially 10 means 5, in that half reduced. Here 20 means how much it will become? 10 molar. So that T half is how much? T half is how much? Initially the T half was what, 2 minutes. So now it is how much? So you can use what, this form, this concept. T half is directly proportional to A. Once A got doubles now, T half also what will happen? Get doubles. You will get what? 4 minutes you will get. Okay. And you can use the same formula also you can use, you will get same thing. T half of 1 by T half of 2 is equal to A1 by what? A2. So T half of 1 was what? 2 minutes, and T half of 2 we have to find out. Initial concentration A was 10, and the second case what we had 20. Then X is equal to what we will get here? What will get 40 by 10 you will get. So what you will get? 4 minutes you will get. Clear? Like this. Okay, like this you can see. And this one. So I told you we will see some problems, right? We will see some problems based on okay, these concepts, right? Okay, so let me give some. So right here I forgot to tell you that okay, units of zero order rate constant. Next one, see, we are going to see units of zero order rate constant. Okay, okay, there is a one general formula that mole power 1 minus n, liter power n minus 1, and second inverse. This is the general formula. In this one, where n is if zero order is means n is equal to 0, if first order means n is equal to 1, if it second order means n is equal to 2. So n may be 0, 1, 2, 3. So we want to write for zero order. So what will happen? Zero order K formula. Okay, K units, what will happen here? K is equal to mole power 1 minus 0. So what you will get? Mole you will get, and liter power 0 minus 1. So liter inverse you will get, and second inverse you will get. Okay, so these units will be same for rate of reaction also. Rate of reaction units as well as zero order rate constant units are same. Many times they asked a question. Okay, what is the reason zero order rate of reaction means you will write dr by dt, you will write difference in the concentration of reactant by dt. So concentration by time only you are taking, correct? So concentration nothing but what, mole by liter by what, second. So same you will get again. For rate of reaction also you will get unit same, mole, okay, liter inverse and second inverse you will get. Okay, this is, suppose if they are asking first order k units, first order k units, now what we can write? We can write mole power 1 minus 1, 0. Mole power 0 means something power 0 now 1. Liter power 1 minus 1. 1 minus 1 means 0. Liter power 0 now what, it is 1. So we will get first order, also we will get what, second inverse. Suppose if they are asking second order, okay, k units they are asking. What we can write? K units means second order k, at the place of n you can substitute 2. So you will get mole power, okay, mole power minus 1 liter and second inverse you will get this one. Okay, like this you have to do. So first we will see some problems now. Okay, based on these concepts we will see some problems. So here right, the question is, rate of reaction is always equal to rate constant, the order of reaction will be. So I told you in the derivation starting itself, rate of reaction is equal to k in what, 0 order. Why? Because rate of reaction was directly proportional to r power 0. Okay, that is only definition. No, the rate of reaction is directly proportional to the concentration of r where power raised to 0. Then ROR is equal to, you will get k into r power 0 you will get. So I told you already, okay, something power 0 is what, 1. Okay, so ROR is equal to k. In which one it is? It is a 0 order. So fourth one option. Okay, so we will see the next problem. Order only. So here a 0 order reaction, 20% of the reaction completes in 10 seconds. How much time will take to complete? Okay, complete 50% of reaction. So here see what we are having. First you have to they are asking to complete 50%, means T of they are asking. First you write T of formula. T of is equal to A by 2K. So a 0 order reaction 20% complete. So we are not we may have A 20% means 100% you can take. Okay, 100 you can take, not a problem. So K you have to find out first. First you have to find out what K you have to find out. So K is equal to, we are having R0 minus R by, okay, T. So R0 value how much here, initial concentration we can take 100 minus, okay, 0 order reaction 20% of reaction completes. So 100 minus, okay, 20 is got completed. So 100 in the 120 complete means how much remaining? Initial concentration is R0 you have taken as a 100, R means final concentration. How much? 20 complete means 80 remains by, okay, by time taken how much, it is 10. So how much you will get? K you will get 20 by 10, you will get what, 2 you will get. K units what here? Okay, mole, liter inverse and second inverse is the units. Okay, so here T half is equal to, we are having A by 2K. Okay, we have found K. Okay, so A is how much you can take? You can take 100%, you can take 100. So 2 into K is how much here? 2. So how much you will get? 100 by 4 you will get. Nothing but what? 25. 25 na, it is what? It is a seconds. 25 seconds. 25 seconds. Okay, so you will get answer is 25 seconds you will get. Okay, 20% completes in 10 seconds na. Okay, it will be T 50% is equal to how much? 25 seconds. Got it? This is the answer. Okay, like this. These are the problems which are involved in a 0 order, and in next video I am going to discuss about first order reaction and first order rate constant we will derive, and we will see half-life how it will be, and related graphs we will see, and some problems also we will discuss in first order. Okay, if you like this video you can share to your friends and subscribe to my channel and leave a comment what and all you required which concepts and all you required, that and all you can comment in the comment box, so I will make the video. Okay, thank you.